When you see a software project fail, it's rarely because of bad code. More often than not, it's because of a bad plan. Today, we're diving into what might be the most critical part of any project, making sure you're building the right thing from the very beginning.
So, here's our game plan. First, we're going to pinpoint the one core problem that every single project runs into. Then, we'll walk through some simple checks to help you dodge disaster. After that, we'll get into the real power of visual blueprints, see how modern engineering puts them front and center, and then wrap it all up with why this entire approach is such a game changer. All right, first up, building the right thing. Before we jump into any solutions, let's really get a handle on the fundamental problem we're all trying to solve here.
Oh man, we've all been there, right? You have this crystal clear idea in your head. You explain it to someone, but what comes back is, well, something else entirely. In the world of software, that gap between the vision and the final product isn't just frustrating. It can be incredibly expensive. This is the exact challenge that great requirements engineering is designed to tackle head-on.
So how do we prevent that from happening? Well, our first line of defense is a set of crucial sanity checks. This is all about validating our understanding before a single line of code is ever written. And here's the key thing to understand about validation. It's not about checking if the requirements are spelled correctly or formatted nicely. No, it's about checking if they describe the correct thing. Are we absolutely 100% sure that this is what the user is actually asking for?
And to do that, we have a whole toolkit of validation techniques. We're going to look at 5 of these proven methods for basically stress testing our requirements to catch any misunderstandings early and often.
Now, the simplest tool in the box is just a good old-fashioned checklist. Think of it as your first pass sanity check. We ask some really straightforward but powerful questions. Is the language actually clear to everyone? Wait, are we contradicting ourselves on page 5 from what we said back on page 2? You'd be amazed how many issues these simple checks can catch right out of the gate. Checklists are great for what's written down, but sometimes you just need to get hands-on, and that's where prototyping comes in. It's like building a mock-up of the software. It lets real users test drive the concept. You give them a few tasks to do, and you watch. And you find out really fast what's confusing, what's missing, or what just feels wrong in the real world. Here are 2 more clever tricks for you. Try writing the user manual way ahead of time. If you can't clearly explain how a feature works, you probably haven't defined it well enough yet. Same idea goes for testing. If you can't figure out how you would even test a requirement, that's a huge red flag that the requirement itself is probably way too vague. Okay, so those checks are absolutely essential. But for really complex systems, words alone just aren't gonna cut it. We need pictures. We need a blueprint. And this quote just says it all, doesn't it? You can have a dense, 100-page document that's confusing and probably hides a ton of contradictions. Or you can have one well-drawn diagram that makes a complex idea instantly clear to everybody.
Just look at this boiler schematic. Even if you're not a plumber, you can pretty much grasp the basic flow, right? You can see how the parts connect and what they do. That's the power of a good model. It makes a complex system understandable, even at a glance.
And software uses the exact same principle, just with layers of blueprints. We start with a high-level business model. Then we drill down into the user features, then into a more detailed analysis model, and so on. It creates this really clear path from a big, abstract idea all the way down to the actual code. So what makes a model a good model? Well, first, it has to be clear even to people outside the engineering team. It needs to be coherent, no weird gaps or confusing holes. And frankly, the tools you use to create and view it should make things easier, not harder. This whole idea leads us straight to a really powerful modern approach that puts these blueprints at the absolute heart of the development process. It's called Model-Driven Requirement Engineering, or MDRE for short. Now with MDRE, the model isn't just some drawing you make and then forget about. No way. It becomes the central source of truth for the entire project. It's the living document that guides every single decision the team makes. Check this out. See how the analysis model sits right there in the middle, like a central hub? It connects everything, the high-level business goals, the detailed test plans, the project schedule, the design. Everyone on the project, from the managers to the testers, is working from this one shared visual understanding. It's powerful stuff. And we use different kinds of models for different jobs. For instance, a use case model is all about the what. What is the user actually trying to do? Then you've got something like a sequence diagram, which dives deep into the how. How do all the different parts of the system work together to make that happen? Let me show you what I mean with a quick example. Okay, here's a use case model. It's super simple and clear, right? An official wants to delete an event, and that one action kicks off a bunch of things, like deleting it from different calendars and a database. We see the goal, the what, purely from the user's point of view.
And now, here's the how. This is the sequence diagram for that very same action. It shows the step-by-step messages being sent between the user interface, the event manager, the calendars, and the database. This is the detailed blueprint the engineers are going to use to build the feature correctly. See the difference?
So you might be thinking, okay, that seems like a lot of work. Why go through all this trouble to create these detailed blueprints? What's the real payoff here?
Well, the benefits are absolutely huge. When you have a clear model, you can estimate cost and time way more accurately. You can manage incredibly complex systems without getting lost in the weeds. And you can review business processes with stakeholders in a way that everyone, and I mean everyone, understands. That leads to better quality and much clearer ways to measure your progress.
What it all boils down to is this. Using models transforms your requirements. They stop being some dusty, static document that nobody ever reads and become a living, dynamic guide that aligns the entire team on a single, shared vision of what they're building and why it matters.
In the end, this is the difference between simply building the thing right and building the right thing. And it leaves you with a final thought to chew on. We use these incredibly detailed blueprints to build our cities, our cars, our machines, so just imagine the future we could build if we applied that same level of care and clarity to the software that runs our entire world.